Okay, good morning, everyone. I wanna continue from the last lecture. In the last lecture, I mentioned about modern electronics, and especially I explained how the DRAM is operated. And as you see in this view graph again, the DRAM is consisted by one transistor and one transistor and one capacitor. And when we scale down the size of DRAM, the capacitance of the capacitor will be decreased. In order to prevent such decreasement, they make such kind of very complex structure, keep the certain amount of capacitance. So they made such kind of very deep trench. That's the very difficult part in a DRAM process. So here is the some example of the details of the structure. You see here, there is one transistor and one capacitor. So this part is a transistor, and this part is a capacitor. And when you see this real photo of the DRAM, we have a very deep trench, and there is some transistor in a bottom. Okay. So how about the transistor? We already learned about the basic of the transistor during your undergraduate course, but the modern transistor is a little bit different structure called the CMOS type, or FET, the field effect transistor. So this is the typical structure of the planar transistor. We have one source and drain, and there is a gate. To control the current from the source to drain, we apply certain voltage in a gate. But when we scale down the size of the gate or the width of the gate is getting weaker and weaker. So people should make some idea to the performance of the transistor. So people designed the three-dimensional, what's called pin type tri-gate transistor. This is, in other words, called the pin type. So there is some source and drain, but in order to increase the number of the contact area of the gate, they make such kind of a three-dimensional structure. Even they made such kind of a more complex structure. They are all three-dimensional structure. And this is the I got this cartoon from the Intel's homepage. Sorry about this is some Korean, but I hope Victor and Leah can understand the meaning. This means the 14 nanometer. And compared to 22 nanometer gate, when people are employing the 14 nanometer gate, oops. Can you see? Okay. Now I think the network connection is not so good. Okay, so when you size down the size of the gate, then you can obtain the performance increasement. So nowadays it's 7 nanometer. It's already half of the 14 nanometer. I'm sorry about this. This cartoon I took from Intel company. Was a little bit old because I made this view graph couple of years ago. Oh, network is so bad. I lost the sharing again. Can you hear my voice? Or the audio is also problem? I saw there's some problem in sharing the application. How about the audio? Keep going. Good. This the reason I'm talking about this gate structure is, as you see here, the engineers in the semiconductor industry tried very, very hard to maintain the performance of the transistor. That's the almost limitation. So as I told you, nowadays it's around 7 nanometer process. But how can you? What's the limitation of the such kind of a number? If you scale down to 3 nanometer, maybe it's possible. There is some report about that 3 nanometer transistor can be made. But how about the next one? Can you go to the 1 nanometer or even to the less than 1 nanometer? That's impossible. That's why we need something new idea to make a better transistor in even smaller size. Okay. Oh, it's terrible. One day it was good. I think it's maybe my problem. I'm gonna connect again. Just wait a moment.